Alright guys, we're going to go ahead and get started today. Today you're going to need your highlighter, your pencil just like normal, and we are flipping to page 20. Right, you should be on the page that says Energy Transformations. I'll give you a second to get there. And let's get started. So, energy transformations, right? This is when energy is changing from one form to another, right? So let's say change from one form to another, right? That's the most important thing for you to know. All energy forms and energy transformations can be traced back to the energy from the sun, right? So everything comes from the sun. Right? Energy transformations happen all around us, and the unit that is used for energy is called joules. It's represented by a J. Right? So let's look at some pictures here. Right? First of all, right, we have to know our different types of energy. Right? So I'm going to write it out to the side. Right? This is our acronym for it. It's MELTS C. Right? So if we can remember these, it's mechanical, electrical, light, thermal, sound, and chemical. Right? So let's look at how that works with our pictures over here. First thing we have is an electrical circuit. Right? This is a battery, and batteries are chemical energy. And that chemical energy is transformed into something as it goes through the wires, right? And wires carry electrical energy, right? So what's happening here is chemical is turning into electrical. And that's the energy transformation, right? Then we have the food web. Right? And the same thing is happening here, right? Because chemical energy cannot just be found in batteries. It's also found in all of the food, right? Any type of stored up potential energy inside something, that is chemical potential energy, right? So this is all chemical to chemical. Right? You could say it's also chemical to mechanical, because you have to eat things in order to be able to move, and these animals are using that chemical energy to do their daily lives, right? So that is another example, right? Let's talk about the roller coaster, right? We talked about this with potential and kinetic energy, right? It has high potential energy at the top, low kinetic, and down at the bottom it has high kinetic and low potential, right? And photosynthesis as well, the energy coming from the sun, as radiant energy. We'll write on this one. And it's transforming into food for the plant, which would be chemical energy, right? So that's radiant to chemical is what's happening on that one. Right? So energy transformations, it's important that we can remember MELT C, mechanical, electrical, light, thermal, sound, chemical, right? And radiant energy is considered light energy, like I said, from the sun, right? That's another name for it, okay? We're going to go ahead and flip the page, right? This whole page, we're going to go ahead and skip, right? So just go ahead and put a big old X on it. We're going to skip that one. Right, we'll come back to questions in a little bit. Keep going, keep going, keep going, and we are on page 28, seasons. Right, this one's a tricky one, right, so we're going to talk about it a little bit more. Right, we need to know what causes seasons. Right, remember there's a couple of things. Right, first of all, it's tilted at an angle. Right, the earth is tilted. That is one of the big parts of why we have seasons. The other reason is that the earth revolves around the sun. Okay? So, that last sentence puts it together. Seasons occur due to the earth's tilt and revolution, right? It's both, right? It's not just one, it's both, right? So the revolution, remember, is when it goes all the way around, right? The sun would be here in the middle. Can't really see it, right? Here, I'll draw it to help us remember. The sun's in the middle, okay? So it is, because it's tilted, it's not straight up and down, it's to the side, right? And because it goes around, right? So let's go ahead and label this picture down here, right? We're going to start with this left one, right? That's the easiest place for me to start, is always on the left and then go around, right? So the northern hemisphere, the top pole, the North Pole, is tilted towards the sun. If you're tilted towards the sun, you're going to be getting more sunlight and more heat, right? So that would have to be summer for that hemisphere. If the northern hemisphere is in summer, then remember, it's always opposite. The southern would be in winter, right? And then we can go straight across, right? From summer over here, right, to, it can't still be summer. Now the northern hemisphere is pointed away from the sun, right? This would be winter. And the southern hemisphere is now pointed towards the sun a little bit, which makes this summer, right? You see how we just took them and we flipped them, okay? Now we have to think about the way it moves, right? It goes counterclockwise, right? If you thought of this whole circle as a clock, right? Remember, clock hands move this way, right? We're moving this way. So let's focus on the northern hemisphere. From summer, the season that comes after summer, right, is fall. Then winter in the northern hemisphere. Then in the northern hemisphere, after winter comes spring. And then we just have to fill it in. Southern hemisphere, after winter comes spring. After spring comes summer. After summer comes fall. And again, you can check. These are opposites. They flip, right? Fall, spring, okay? Right, northern hemisphere, southern hemisphere down here, right? Quick review, the equator divides it, right? The northern hemisphere is above the equator, the southern hemisphere is below it, right? And they're always experiencing opposite seasons. That's what I'm saying here, right? These are opposites, summer and winter, right? They don't happen at the same time, right? Then it flips over there. Those are opposites, okay? All right, we're going to go ahead and skip that part just for time and go to tides, right? Tides, tricky tides. Right, tides are the rising and falling of the ocean, right? Rising and falling of the ocean, right? They happen because of gravitational attraction between the sun, earth, and moon, okay? The moon's gravity has a bigger impact on the tides because it's closer. So the moon's gravity has a bigger impact because it's closer to Earth. Whoops, typo. That's not spelled right. We can fix that. Earth. Then it has the sun. All right, there's 2 tides a day, right? There's 2 high tides, 2 low tides. That happens in 24 hours. So 2 times in a day, the water is going to go up to the highest it can go, and then it's going to go down to the lowest it can go. Right? Like I said, high tide, right, when it's at the highest level, low tides when it's at the lowest. Right? Draw the bulge of water around the earth, and draw 2 arrows pointing to the location of the high tides, okay? So we're going to draw the bulge of water, right? We haven't done this in a while, right? So remember, it looks like this, right? And that's representing all the oceans on the earth, right? Obviously, it doesn't go up that high, right? That's just to help us see it a little bit. So we're going to do that on both earths. Draw your bulge. Right? And then we're supposed to draw arrows to the high tides, right? Well, the high tides are going to be where the water is the highest, right? So this would be high tide, and this would be high tide. right? The opposite on this one, right? It's going to be where the water is closer to the earth. That would be low tide. That would be low tide. Got it? Moving on. Here's the tricky part about tides when we get into spring and neap tides. Okay? Right? So, spring tides, remember we have some ways to remember this, right? So this is going to help us. Right? Spring tide is the difference between the high tide and the low tide is the greatest. Right? That means it pulls the most. Right? It is the strongest. Right? Remember we said spring, straight, strong. Right? SSS. Right? Spring, straight, strong, right? It pulls the water more because the moon and the sun are working together. That's why they're in a straight line, okay? So remember, spring straight, right? And we're also going to add strong to that, okay? Then we have neap, right? That's when there's the least amount of difference because the moon's pulling one way and the sun's pulling the other, making a 90-degree angle. And our reminder is neap 90 weak. Spring straight strong, neap 90 weak. We need to draw some pictures of that. Spring tide first, right? Earth is going to go in the middle. I'm going to give it an E so I can remember. Sun goes on one side. Let's label it. Moon goes on the other. Give it an M. Right, and then I'm going to draw some little dotted lines to remind us that it is in a straight line. Let's draw an arrow underneath it too. Let's go ahead and write it out. Spring, straight, strong. Right, we're going to do the same thing down here, but draw a neap tide. Right, again, let's draw the earth. Give it an E. Let's put the sun in the same spot, out to the side. Sun. And the moon now goes up here because now we're making a 90-degree angle here. Right? I'm going to draw it. 90-degree angle. Neap. 90 weak. Right? Make sure you have that on yours as well. Neap 90 weak. Spring straight strong. It's in a straight line. It is strong and pulling those tides. So the high tide is higher than normal and the low tide is lower than normal. Neap 90 weak. Right? They're working against each other so it's weaker. Right? It doesn't pull the water as much. Okay? Got it? We move into Earth's spheres. Right, there are 4 spheres that make up the Earth. Right, they are labeled on here. Right, biosphere, hydrosphere, atmosphere, geosphere. Right, it hasn't been that long since we've talked about this. Right, the spheres interact with each other. Humans have a major impact on the Earth. Right. Easy peasy, right? Not too crazy, right? We got to remember what our prefixes mean for these spheres, right? For the biosphere, bio means life, and it's made up of all the living things on Earth, right? So let's just draw one example. What's something living from the Earth? I see a duck right here. There's some trees, right? Let's draw let's draw a flower. Okay, there's my flower. Alright, go ahead. I want you to draw one more thing in this box right here that would count in the biosphere. You can draw whatever you want. It just has to be something that is alive. I'll pause for a second. Alright, let's go talk about the other spheres now. Right, now we have hydrosphere. Right, remember hydro means water, like hydrated. right? You get hydrated when you drink water. So this is all the water in the oceans, in the rivers, in the lakes, the water you drink, the water inside of you, right? Because you are made up of water, right? The water in the plants, right? Everything that is water, rain, snow, sleet, hail, clouds. Clouds are made up of water vapor, right? This is all examples, right? So we're going to draw one. I'm going to draw some clouds. Draw a cloud with me. And draw one more example of your own. I just gave you a billion examples. Go ahead and draw one. The next one is atmosphere. Atmos means air, right? This one's easy because we can remember it, right? Lots of us have already heard the word atmosphere, right? The atmosphere is all the gases that surround the earth, right? I'm going to draw oxygen, and let's say, I don't know, I'm going to do a balloon. A balloon, right? Just because it is full of gases and air that we can breathe in, right? You draw another example. A good example could be oxygen, could be air in a hot air balloon, could be playing an instrument, all sorts of things, right? You draw your example. Last one is geosphere. Geo means earth. It's also referred to as the lithosphere, right? Lithosphere, like we talked about in the layers of the earth. And this is all of the land, the rocks, the dirt, everything, right? So I'm going to draw a big old rock. Looks like the rock that Patrick lives under. All right, just a rock, right? Nothing fancy. Maybe some speckles, some sediments in it. Right? You draw one more example for the geosphere. Anything that has to do with the rocks, the dirt, the minerals, crystals, anything like that. Let's get one more page in. We're doing layers of the earth. We did so many models for the layers. Our picture down here sadly doesn't look great, but we're going to still get them in order. First one is the crust, right? If you were here when we did the Rice Krispie Treat Lab, right, this was our graham cracker, right? We used the frosting to adhere the graham cracker, that goes together, right? Remember, this is rocky, right? There are two types of crust. There's a continental and oceanic. This is the thinnest and the coolest layer, right? So we're going to draw out to the side, thinnest layer. It is also the coolest. Right, then we have the lithosphere, that's what we were just talking about, the rock. Right, this is part of the crust, right? You see this right here. Right, it's talking about it's the top part of the crust into the mantle. So all of this is the lithosphere, right? Less important for us to know, right? This is where tectonic plates happen. You're going to learn about this next year, right? This is more of a 7th grade thing. So lithosphere and asthenosphere, right? We're going to kind of jump past those because remember, we're focused on the main 4. Crust is the first one. Next one is the mantle. This is the thickest layer, right? Super thick. It is made up of semi-solid magma, and it's warmer than the crust, right? As we go down, it just keeps getting hotter, okay? So you can see range in temperature from 500 to 4,000 degrees Celsius, right? And we're going to keep getting warmer as we go. Then we have the outer core, right? This one is made up of iron and nickel. It's made up of liquid iron and nickel. That's important, right? This is molten metals, liquid metals. And on the inside we have the inner core, right? It is solid metals because of the pressure. That's important for you to know, right? The inner core is solid even though it's the same thing as the outer core, right, because of all the pressure that the Earth's putting on it. And it is the hottest, right, at 6,000 degrees Celsius. So it only gets hotter as we go to the middle, okay? I forgot to mention, right, we said crust was our graham cracker level, right? Then we went down, right? The next layer was our Rice Krispie treat. Our Rice Krispie treat we molded around the marshmallow, and inside of the marshmallow we had the cherry, right? So the cherry was solid, right? We imagined that our marshmallow was liquid, right? We said it was squishy, right? Same idea, right? That should have been liquid. Our mantle was our Rice Krispie treat. It's semi-solid, you could mold it. And then the crust was the thinnest layer up at the top. So let's label these in order. This box is pointing to the outside. That would be the crust, right? Then the next box pointing to the next layer is this one, would be the mantle. The next one is this one, right? That's the outer core. The next one is the very inside, and that is the inner core. All right, we're done with notes for today. We're going to go back and look at the questions we are working with. So we started with energy transformations today, right? The questions for energy transformations start on page 26, right? Remember, we crossed out the waves one. We're not doing the waves questions, so you can put a big ol' X. This is page 27. We're not going to do those questions, right? But we are doing 9 and 10 on page 26. Then flip forward all the way through all of this good stuff that we just worked on. Not rocks, we're not there yet. Right, we talked about seasons. We're doing question 1 and 2. That's on page 37. We talked about tides. We're doing 3 and 4. We still talked about more tides. We got 5. That's page 39. Keep going. Lots of questions today. More tides. We talked about the Earth's spheres. We had a 2-part question here on page 40. Don't miss both parts. Page 41, this is question 8. And last 2, we're doing 9 and 10. So you have a ton of questions to answer today. You're going to have to work quickly, right? That was a total of 12 questions that we are doing, right? So make sure that you are staying on task with your team, you're getting working quickly, and then you're ranking the questions 1 through 12 after you finish. Right? Good job, guys. Get started.